Hey everybody, this is Larry. This is day 18 of the Leetcode Day Challenge. Hit the like button, hit the subscribe button, join me on, or day 19, whoops, of the Leetcode Day Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem. So I have solved this before. Yeah, Erect defense. This is kind of a silly problem. Oh, look, I think my glasses are really like reflective. You can barely see my eyes, which is kind of weird. But I don't know. I'm trying to get a better, consistent sleeping schedule. Um, yeah. Today's problem is Erect defense, and I kind of know this one. So that's why I'm like kind of just like thinking about what to do about it because this is a very very silly problem. I would almost say that this is one of those problems that no, it's fun to learn. If you want to learn something cool, learn something fun, learn something new, this is fine. If you don't, that's also fine. If you get this on an interview, either you're doing something really, I don't know, maybe if you're working for a mapping company or something, maybe that'll be kind of a cool thing to learn about computational geometry, which is a field that I actually studied a lot in my undergrad days. So that's why I have some relevant experience. But kind of use this for, I mean, yeah, I mean, I wouldn't say use this, but just like it doesn't come up on interviews, I guess is what I'm trying to say. Yeah, and I'm gonna type this here, unless I'm missing the point. No, it's Convex. Just want to make sure I was reading the same point. I guess I did eventually solved it, but there are so from first principles, there are a couple of algorithms that you can learn, but really, Convex Hole is to a computational geometry problem the same way that sorting is to another type of problem, say, right, where with that then you can do certain with sorting, you're giving these input, you sort it, so you get a sort of a structure, so you could do other things to it in a more straightforward way. And convex hull is the same with computational geometry, and also convex hull is a research, or at least in the past, a topic of much research, kind of like, and I like using the sorting analogy. There's actually some fun things there too, and this is everything is off my head. So if I'm saying something wrong, and I didn't prepare for this, so definitely if I say something wrong, please correct me in the comments. I always do these live. I don't study for these, even for random topics like this, even though it might appear because I just happen to have the experience. And you know me in general, like I don't think I'm afraid to admit I don't know something. So so I hope that doesn't come off as too polished, if that could be a thing. But anyway, but what I was going to say about comics is there's a lot of fun things, and I get geeked out about talking about these things sometimes. That's why I'm like saying a lot before. But also, if you want to skip to the problem, maybe skip ahead. But comics it's that's the entire problem, right? There's nothing interesting except for the comics except for today's Friday, and I feel I have a sort of energy to talk about comics but one thing that's relating comics and sorting is in a 2D comics you can actually prove the lower bound of comics to be n log n. We'll talk about that in a second, because you can reduce a comics problem to a sorting problem, meaning that if you can it's kind of dirty. If you could solve convex hull in faster than n log n, then you can sort faster than n log n in a comparison based kind of way. And of course, proof by contradiction. So so convex hull in 2D at least is going to be in n log n. Of course, there are also higher dimension convex hulls, which I'm not going to talk about that much. That even comes up even less. But one thing, so I'm going to go over very briefly. I'm not going to show all the code or everything. I haven't really decided. I think there are a couple of algorithms that I like, but again, do a Google, do a Wikipedia. Comics there's so much literature. I cannot talk about all the literature, and like I said, I didn't really prepare like a lesson plan on comics so I'm probably going to miss something cool and important. So definitely do your research on it. But one thing I do want to say that is cool about comics additional, there are many cool things, but one thing for now is that it is actually one of the examples that I use as something that is called output sensitive algorithms, right? Or complexity maybe. But what I mean by that is that like we said, we already proved that there's n log n lower bound. So why are we creating more algorithms? Well, it turns out that in a convex hull, you can also define other variables that you can analyze the complexity on. And for example, I think it's commonly known as H, where H is the number of points on the hull, right? And as such, there are actually algorithms that are kind of have some really weird, funky name. I forgot the professor's name who wrote a lot of these, but basically the TLDR is that there are apparently algorithms that could be L log H instead of n log n. That's n log H instead of n log n, which of course in the worst case is still going to be n log n. But if you have a small thing, that can be n log H. I'm also not probably going to go over any of these because they're really kind of complex. But I will go over one, like if you have to have a pinch, because these things I can prove from first principles. So I don't actually remember like the code because I haven't coded this in a while. I guess maybe I've coded at some point. Maybe I just copy and paste into it, to be honest, at some point in the past. But I don't know. Maybe I already have a video out. But basically, I have two kind of algorithms that I like to think about when I do convex hull. And one of them is just mostly for teaching purposes. And you may kind of know it. It's called, the first one will be GIF wrapping. And GIF wrapping is n squared because, well, we'll go over the algorithm really quickly. And let me take out my drawing pad. Okay. Let me also copy this example. Yeah, so let's say you have something like this, right? So then the GIF wrapping algorithm is actually pretty easy to remember, for me anyway. One is just you could pick any extreme point, and because if you pick an extreme point, that's guaranteed to be on the convex hull, right? One of and there are a couple of places you can do it. For example, you could choose like the lowest one that's on the left, or left lowermost or something like this. So let's just say this one. There may be some type working, and then here, you kind of look at every other point, right? And then basically choose the rightmost. I mean, maybe you're gonna choose the leftmost. I forget the convention, but either way, it doesn't matter, right? You can kind of guess that it comes at the same one. So then the rightmost is going to be, it doesn't let me go. Okay, let's just say leftmost because it doesn't let me undo that far. So leftmost is this one, then it goes to this one. And then this one now, it scans, it looks at all of these and then it goes to this one, right? And it goes to this one, and then it goes to this one. Don't know how. Yeah. And then it goes to this one. And then now you have the convex hull. So that is called GIF wrapping because basically you start with a point and you kind of wrap it all the way around. And of course, and so the analysis is kind of simple, right? So you have n points for possibly on the hull, and for each one, you look at n other points, roughly speaking. I mean, you could do some elimination in the middle, but in the worst case, you have to look at each one. So this is going to be n squared. And the way that I also like to kind of explain this one is that this is also O of h, n times h. And the reason why that is because if you think about it, you only have to wrap the GIF h times. And so for each of those h times, you look at n other elements. So that means that if there are only 3 points on the convex hull, meaning you have a triangle and a lot of points in the middle, you only have to do it 3 times n. But 3 h is equal to 3, right? So that's an example of an output sensitive algorithm, and that is something that I find very cool. That's why I like explaining it. But that's basically how a lot of these other things are kind of structured. There are a lot of other algorithms there that are kind of there are a lot of like divide and conquer. For example, I think the one that people use is quick hull, which is same as quick sort, is that you divide and then there's a merge step, which is so you divide it into halves, and then the merge step is linear, and then and then you have the same recurrence and also the same kind of thing. I'm not going to go over that one. That was pretty much it, really. But if you want to think about it a little bit more, then you can do that. The one that I always like to write, at least the gift wrapping obviously is n squared. So and given the n is 3000 is probably no good. The other one that I've called, I believe is called, I'm kind of blanking out on the name. I think it's monotone chain. Monotonic chain, maybe. Let me Google that. No, it's monotone chain. It's been a while though, to be honest. But yeah, but the idea here is, let me also bring the drawing back up. Yeah, the idea here is, maybe I don't need this particular drawing because it's a little bit small for it, but basically you have a lot of points, right? And then the idea here is that the convex hull contains two chains, if you will. One is going to be, and they're going to be monotonically increasing in slope. So that means that in the bottom, basically you're trying to find the bottom half of the convex hull and then the top half of the convex hull. Of course, there's some degenerate cases with vertical lines, but ignoring that for now, basically, for example, this will go to here, this will go to here, this could go to here, and then so forth, and that's the lower chain. And then the same for the upper chain, right? So this kind of feels like what we already did with gift wrapping, you may ask. So what is different from this one, right? So different in this one is that now, you can sort the elements. Sort all the points from left to right, say, right? I mean, I guess there are many ways to sort, but then now, because you're sorting it, then using an n log n, you can construct this mono chain in linear time after sorting. So it's still gonna be n log n, but after this, and this is kind of basically has the same concept with monostack or something like this, where basically for example, let's just say here you start with here on this one. Let me draw this one, and then initially it's going to think the chain is here, and then now it looks at the next number. Remember, going from left to right, it's going to go here, and then because of that, it just it pops that off because, well, this is lower. Next, it's going to try to come here, and then again, it'll pop here, and then go to here. Again, then it goes here, and then it goes, oops, what's going on? And then it goes here, and then it goes maybe here, and then it goes here, and so forth, right? So everything so the TLDR, though, is that because of this sorting structure, you're able to kind of construct a lower chain in linear time after sorting. So this is going to be n log n. So the key thing to take away from me anyway, or from me maybe, or for me, either way. But the reason why I use this one is because it's an n log n algorithm. That's kind of TLDR. Yeah, and that's pretty much that. So these are the ideas that I have in my head, right? So I haven't implemented these in years, so, well, maybe that's not true apparently. I don't know when I kind of got this solved before, but it definitely has been a while, and I'm going to try to do it off my head. And today I'm going to do the monotone chain, so bear with me if I kind of make some mistakes. Yeah, so let's kind of get started. So let's just say we could just sort, so sort by X and then Y, right? Yeah. So that should be okay on the sorting. And then now, so yeah, I'm trying to think about how to clean it, code it, but I think the first thing I'm trying to do here, because it's my first time in a while, is to get it correct in the first place. So the code may not be as clean as, some of the stuff that I'm more practiced in. Specifically, if you think about the top of the chain and the bottom of the chain, you can probably do some rotational thing to kind of calculate them, etc. I'm going to do them in two different cases so that it's more specific, because I don't want to kind of mess things up. But yeah. Also, this is, does it always have to have? Okay. I was just wondering like the degenerate cases, because depending on the problem, they might want to answer the degenerate cases differently. So yeah, this is very awkward though. Do I have to do it in the order? I guess not. It's a little bit awkward, but it's fine. So let's just focus on the lower chain, right? So yeah, so then we take the min element, which should be the first element. Let's print out the tree real quick, just for my sanity, real quick. Is my drawing still blocking the screen? No, okay. Just want to make sure. Okay, so that means that this is going to be leftmost, and the tiebreaker is going to be bottom. So okay, yeah. Okay, so yeah, I think. Okay, yeah. I'm still just thinking about like the degenerate case where you have vertical things. So yeah, so okay, yeah. So let's just say, I guess for both chains you want to start at the same one anyway and end at the same one ideally. Otherwise, bad things will happen. So, yeah. Okay, so starting is equal to trees up 0, and then now for I in range of n from 1 to n, let's just say n is the length of trees, right? And then now maybe we have a stack, right? And the idea here is same as the other one, which is you want the rightmost thing. And of course, so one thing that I would say, and this is probably from experience, so you know, but I am a little bit bad about this just because I haven't done it in a long time, and I've been kind of talking already for about 16 minutes before coding. But the idea here, of course, or the one that I want to convey is there are a couple of ways to do the angles to do the rightmost. The way that I do it is with what do you call it? Dot product, right? Basically, the dot product gives you the triangle of, the area under the triangle, right? And so, but it's assigned the area under the triangle so that you can kind of figure out if it's positive, it's on one side, if it's negative on the other. If it's 0, then it's just a line. So that's basically what I'm trying to do. I'll put some comments in, in my code, but I'm gonna put some comments on my code, but I probably am not gonna explain that much. This is stuff that comes up in linear algebra. And also just, I don't know, I don't remember what math teaches this, but like really early on, and this is half my lifetime ago, so I don't remember that much. But let's just, something for you to Google if you really wanted to learn more about it. But yeah, but I'm just gonna leave that here, and maybe I can even do a depth area of AXAY, BXBY, CXCY, and then basically area of the triangle ABC. I guess that part is just kind of useless to comment. But and this time Is it the dot product, or did I mess it up? Did that mean cross product? I mean, dot product can. Yeah, no, I mean, this is right. Okay. So basically, this is part that I'm worried about because it is easy to get wrong. Okay, something like that. Yeah. Is it cross product? Am I confusing things? It's been a while. Wow. Huh. I think I meant cross product, didn't I? Huh. Do I? Man. I am so very bad at this. Sorry, friends. But yeah. I think this is fine either way. And actually, I would say the notation that I actually usually use is area 2 because this actually returns the area of the parallelogram and not the triangle. But because the reason why I do it this way is because we can keep everything in integers instead of using floats, which may be a mess. Because and all we have to care about is whether all we have to care about is whether it is positive, 0, or negative, right? So we don't actually care about this number per se. So that's why I'm able to do this. Okay, so then now let's just say, how do I set this up? Okay, so we have a stack. Okay. I'm trying to think about the order that I'm trying to do. I mean, we have the idea, and like I said, I'm trying to, prove these things from first principle. But basically, yeah, let's say we have 1 point and then second point. Okay, good. And then now we have a third point. So then do. Okay, so do we pop? Okay, fine. And then we put it in. Okay. And then let's say we have to. What if we have a lower point? Then first we could do this is to the right. So then we pop that and then. Okay, I guess that works. I guess that works, right? So okay, so if, or maybe while length of stack, and we should stack with starting maybe, while is greater than equal to 2, or equals to, I guess we can just do it. No, yeah, I guess something like this. Okay, and then yeah, how do I want to say it? So basically, if I have to make sure I get this right. Sorry. So maybe I should have done this as APC instead of AX by X, but yeah, it's not too late. Okay, fine. So then now, basically, if the angle of the first two and 3 sub I, if this is to the right, I sometimes I get these signs wrong because I know there's a rule, but I don't know. It's been a long time. I'm old, sorry. So this then stack dot pop. Oops, keyboard on the wrong place. Stack dot pop, and then stack dot append. Yeah. Okay. 3 sub I. Okay, and then I'm just gonna print it out. Just stack, just to kind of see if we're on the right idea. I mean, well, we didn't do anything, so okay. So 1 1. Oh wait, what am I putting up? 1 1 2 0. 2 2. So it goes from do, which is I guess technically right, and then 2 4 also technically right because they're collinear, and then 3 3. Do. This is definitely no. We need to pop the 2 4. So maybe I got the directions wrong. Oh no. Whoops. That's why, because it's why did I do it that way? I think I was just thinking about the 3 element case and I got confused. Okay. So yeah, so 1 1. Oh no, wait. I'm looking at the one. Okay, 1 1 2 4 3 3 4 2. I mean, I think I did the upper bound by accident. So let's kind of focus on the other one real quick. I think my original sign was right, but then yeah. Okay, 112042. Okay, so I think this is pretty much it, really. This is the chain, but and then we just have to do it again for the top. So yeah, I'm just trying to think whether I might do something weird and cross over, but I think this is maybe mostly right. Okay. So then points is equal to set, and then I'm kind of lazy, so I'm just gonna is it add or extend or something? Let's do something like that. Okay, fine. And then now we do the same for the like I said, I would is it dot product or cross product? I think that's up to you to figure it out. Yeah. And then points is equal to set of stack again. No. Is there a set extend? Oh wait, something like this, right? Maybe that's fine, right? And then we return points. We have to make a list of it. No. Unhashable type list. I thought there's a thing where like, can I mess it up? Like there's a thing where you can do a set for the elements, right? Did I mess that up? And man, I'm just is that not how I do it? That seems how I do it, right? So unhashable item list. Oh, because each okay, fine. That's annoying, actually. But I'm just gonna convert them to tuple because I'm lazy. Don't do this at home, please. So it looks good. Again, this is to take the bottom chain and the top chain. I just do the same thing, but I use leftmost now. I didn't know, I wasn't sure, to be honest, that I could do that, but it kind of makes sense, right? Because if you go to leftmost, then you always get the upper range. Let's give it a submit. It's very possible that I kind of messed up on the ending case because I was a little bit lazy, but it seems okay. And apparently this is a pretty fast solution because I don't know, 963-day streak, and that's pretty much all I have. Like I said, this is going to be dominated by the sorting. Everything else is going to be linear with just 2 stacks. One for the top. Oh, sorry, I think this is bottom chain, and then this is top chain. But yeah, I think one thing I want to also just add additionally is that I think a lot of people kind of ask me about my language choices and stuff like that in the past. And you know, at the end of the day, the language is just your tool, right? What I want you to focus on is kind of figuring out how to understand and solve the problem from a place where you have good understanding. For example, the TLDR of what I want to say is that everything that I explained to you is not prepared, or at least not like immediately prepared. Maybe I guess I studied like years ago or whatever. But what I mean is that, yeah, everything I said to you now is off my head, right? So now hopefully, I mean, maybe you don't need to get to the point that I am, as you know, I'm a super nerd or whatever, but hopefully you are able to kind of, you know, take some of the core concepts like GIF wrapping is pretty like, you know, it's pretty intuitive to understand, and this one also as well. It's just a couple of concepts that when you do it, then the coding, you know, maybe I'm a little bit slower than if I had studied and memorized it or whatever, but everything you see here, and maybe, you know, maybe this part I should have, I don't know. Like I said, I may be wrong in some of this stuff because now I'm doubting myself whether this is a dot product or cross product. So leave in the comments which one it is. But my point is still that, you know, with these concepts, everything, you know, you saw me coding it, right? So yeah, and the other part, of course, is just have a little confidence in yourself, even if things go wrong. And I'm not gonna lie, I wasn't 100% sure, mostly due to how to handle degeneracies. What I mean by that isn't like a Wall Street bet thing, but more like a line situation. And that will come with experience, because basically what you want to do is just pop if they're aligned. So that actually is not that hard to solve in this particular case, but that also requires understanding of what you're actually doing and not just copying and pasting the code. So yeah, and you may also solve this in other ways, like trying to find the arc cosine of the thing by you have a triangle, you have two lines, the cosine is the thing, and then you have two lines, you have a triangle, you find a cosine by taking the arc cosine of these things, right? That's also experience as well. Just thinking about it in terms of pure integer as much as you can. So definitely some learning experience, some learning opportunity there. But pretty much that's all I have. So yeah, let me know what you think. And I kind of got lazy with the just putting everything in a set, but it's fine. I think it's okay. Because you can actually, this is actually the chain in order if you did need it in order. But I was kind of too lazy to dedupe between the two of them. I think only I think it depends on. This is such a weird problem because of the degeneracies as well. Because, like, for example, this line isn't really a Convex tool per se, but depending on how you want to define it, but it depends on the problem. Anyway, that's all I have for this one, though. I've been talking a lot, and I don't know how long I end up actually coding, but hopefully it was, useful and insightful. And like I said, everything I do here is live as much as I can. I mean, sometimes I get interrupted, so I don't know. I think that anyway. But anyway, it is the weekend. Hope you enjoy the weekend. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.